Hello, welcome back to Mayday Flight Tutoring videos. I have yet another in a line of videos that I've been making over the summer here in Berlin, Germany, as I take a break from flying, which is soon to end on September 5th. I'll be back in Canada and flight instructing again. Today I want to talk about air pressure, altitude, and altimeters. All right. And I want to talk about this because it's a subject that confuses some people, and it's good for me to just sort of talk it out, right? Because it helps me practice when I'm instructing and trying to instruct a student as to what exactly their altimeter means when they look at their altimeter in terms of like air pressure and height above sea level. Of course, we use two types of height. We use ground level and sea level very commonly in flying. But in actual fact, I have six different types of pressure that we can talk about that you'll find in all the books, and a seventh related density altitude, which is not so much a pressure thing as it is an air density and aircraft performance, takeoff, landing. I lump that under the same subject because there is some confusion with some people about the difference between density, altitude, and say an altimeter setting. So without further ado, I have this little notebook here that I've been using. And you may all recognize that if you've been watching my videos. And I made a diagram to discuss these different types of altitudes. I tried to imagine, like, to help me think it through and sort of understand the subject. I imagine, well, what if you had like a sea base, seaplane here, and right beside that in the same region, like say it's an island on the ocean, 1,000-foot high airport. So they're side by each here. They're just like, say, I don't know, a kilometer apart. So they're under the same air pressure regime. Whatever pressure system has come in is the same. And that helps me kind of understand the differences of types of pressure and how they relate to the altimeter. And hopefully I can explain that. Starting with sea level pressure, which is it's the local pressure variant based on 29.92 inches mercury, which we all call the standard pressure. You've all heard the standard pressure, standard temperature of 15 degrees Celsius, because temperature affects air pressure. It's based on weather pressure systems, because the thing is that if you're on a seaplane and you're at sea level and you set your altimeter to 0 feet because you're at sea level, then whatever shows up in your altimeter window, whatever inches mercury shows up, would correspond to the pressure of the day. Okay, so if you had a low pressure day, that you'd still zero your altimeter, you're going to have a different amount of inches mercury, a lower amount of inches mercury of pressure than you would say on a high pressure day. But that's always corrected for 0 feet. So if you have an altimeter at sea level, it should read 0. Then in that window is going to be the pressure system that the airplanes live in. Makes sense. So people say, okay, well, what exactly is an altimeter setting at an airport that's not at sea level? Well, I put this airport about a kilometer away. So it's in the same air pressure regime. So if that airplane is 1,000 feet above sea level on this little mountain here, right? And we all know, or should remember, that for each increase of height of 1,000 feet, the air pressure goes down by 1 inch mercury. So if on that day, it just so happened that it was a standard pressure day and the altimeter was set to 0 and was reading 29.92 inches mercury, well then, with 1,000 feet of height, the altimeter set to 1,000 would show 28.92 inches mercury. Okay, so basically that altimeter setting is corrected from the distance from sea level. All right, so when you have like sea level and a higher elevation airport right together, you're in the same pressure regime. It's very easy to see that, but this is a very rare thing. You know, for example, in Winnipeg, Manitoba is roughly 1,000 feet above sea level. But at any given day, it's going to be under a different air pressure condition than, say, an airport at sea level, either off the coast of Vancouver or Halifax. So the air pressure is not the same. So it's not going to be a simple mathematical correlation from zero. In other words, if it's 2992 in the Halifax Harbor at sea level, it's not necessarily going to be 2892 in Winnipeg, because the air pressure around Winnipeg is going to be a different weather system. So that's going to affect the altimeter setting. But still, we have the standard 29.92, which we can latch onto. All right, it's the anchor from which all the other adjustments are made. So basically, if you're in Winnipeg, Manitoba, and you put your altimeter to the airfield elevation, say, for example, it's 1,000 feet, whatever you read in that window is actually going to be the pressure altitude, okay? And the pressure altitude is an absolute altitude in terms of air pressure, not in terms of height, okay? So, then if you correct it down to 2992, a higher pressure, then of course it would be 1,000 feet lower. However, the air pressure is not the same in different parts of the country at the same time. So what they do is they always correct to mean sea level. All right. So in other words, what the air pressure is where you are in pressure altitude, all right, compared to mean sea level, and at the height from sea level that your airfield is at. All right. So altimeter setting is not pressure altitude because of the weather system that it's in. It's whatever gets you the field elevation on the altimeter will be the altimeter setting. And if you ask for an altimeter setting for an airport that you're flying into, or that's given to you by the controller, then when you land, if you set it to that altimeter setting, you will be the altimeter will read the height above sea level, mean sea level, average sea level, okay, that the field that you landed in is. All right. So let's talk about pressure altitude then. Well, what exactly is pressure altitude? Well, pressure altitude is simply a measurement compared to 29.92, which is the standard. So just like if you set the altimeter setting, the correct altimeter setting, which has been worked out by the meteorology folks, corrected from sea level upwards, all right? And then you landed, of course, the height of the field would be what's reading on the altimeter. But for example, if you're sitting in an airport, say in Winnipeg, Manitoba, and you're showing 3012 on the altimeter for 888 feet. Well, if you just turn the dial until you get 29.92 in the window, then what you read in feet is going to be the pressure altitude, okay? And that's basically a comparison from 2992. So the pressure altitude, the weight of a column of air. All right. Another way to calculate pressure altitude is to take 29.92, all right, minus whatever altimeter setting you have where you are. All right. And if it's a negative number, then you subtract that from your indicated altitude, and that'll give you the pressure altitude. Or if it's a positive number, then you add that to the indicated altitude, and that'll give you the pressure altitude. The pressure altitude is not accurate in terms of determining your height above the ground, all right? So that's important to remember. But that's pressure altitude. So there's two ways to calculate it. One is just simply dial 2992 into your altimeter, and it'll indicate the pressure altitude. And the other way is to take 2992 and subtract whatever the altimeter setting that you're given is, then either add or subtract that amount from your indicated altitude, and that'll be the pressure altitude, right? So the fourth type is true altitude. Now, true altitude is pressure altitude corrected for temperature, okay? Now, those of you who have an E6B whiz wheel, you can calculate true altitude directly in the E6B whiz wheel. Interestingly and unfortunately, the CX6 and the CX3 electronic flight calculators don't actually give you a true altitude function. So that's kind of unfortunate. But the idea with true altitude, and I think, what did I write in my book here? It's you take it. It's calculated by pressure, altitude, corrected for temperature. All right, and what that can allow you to do is, because you have to understand that when you're in a column of air, all right, the air is less dense up high and more dense down low. All right, if the air is colder, the air molecules get closer together, right, and they get heavier and they compress downward. So you may think you're at 1,000 feet, but if it's like, and this is all based on a deviation from standard temperature, all right, which I'll get into in a second. But basically, as the colder the air gets, the lower down the thicker compressed particles are to the ground, and also the lower down the more thinly dispersed molecules are. In other words, the entire column of air compresses down like a sponge. All right. Now, pressure altitude assumes 15 degrees Celsius as the standard. And as you know, we have what's called the lapse rate. So the higher you go up in altitude, right, the cooler the air gets, right, by 2 degrees per Celsius, 1.98 degrees Celsius. All right. So a standard pressure day at sea level of, say, 15 degrees, all right, would not be 15 degrees at 1,000 feet. All right, it would be 13 degrees, 2 degrees on average Celsius cooler. So a standard pressure at 1,000 feet should not be 15 degrees. That 15 degrees is at sea, it's at sea level. All right. Anything above that, you just use the lapse rate to calculate what the standard temperature should be. All right. So standard 15 on a given day at sea level should be 13 at 1,000 feet, should be 11 at 2,000 feet. All right. Now, if you have colder or warmer air, all right, warmer air in that column of air is going to expand upwards, all right, and colder air is going to compress downwards. The altimeter doesn't know the difference from the temperature, and it just looks at pressure altitude, all right. So you need to be able to calculate the pressure altitude, because that's all an altimeter is a pressure altimeter, all right, with an adjustable wheel, all right. So you can change the altimeter setting, which is basically the barometric setting changes from day to day to day. So that's why you're always changing your altimeter every day you go to the airport. You got a different air pressure regime that you're in, and you want to correct it against that standard 2992 at sea level. All right. So on a cold day, imagine, right, the airspeed you're at, like, let's just use my fingers here, okay? So where my glasses are is where the airplane is, okay? And it's reading, I don't know, say 10,000 feet, all right? On a colder day, all right, what's going to happen is, compared to the actual height that you're at, as the air compresses, see how my glasses go down? All right. It's still the same place relative from the bottom of the column of the air to space, to outer space. That's going to read that pressure altitude. So as the air compresses, right, you're actually going to be lower on a colder day in absolute or real altitude from the ground or the water than you would be on a warmer than standard day. All right. So if the air expands upwards on a warmer day, it's still going to be the same amount of molecules that make that pressure altitude indication on your altimeter. And so the plane may have to be a little bit higher in actual height to get the same amount of molecules on a warmer day. And it may be actually a little bit lower on a colder day to get to read the same amount of molecules that give the pressure to it that gives it the indication of the altitude. So why is this important? Well, say you're clearing a mountain by, I don't know, 300 feet, because that's you're at kind of like the limit of how high you can climb, right? And you've calculated that at I don't know, 15,000 feet, 15,000 feet ASL. The mountains actually only top out at 14,800 feet ASL. So you got a 200-foot clearance, so you know you're going to make it over the mountain. Yeah, well, if it's a colder than standard temperature day, you will believe, and it will be true, that the pressure altitude, which is all your altimeter can give you, is reading 15,000 feet. But in actual fact, with that cold air, that pressure level where my glasses are is now lower in absolute altitude or real altitude, all right, for the same reading because all the air is compressed down and heavier, right? So you're not going to clear. You might actually hit the side of the mountain because the mountain is not affected by the air pressure, but your altimeter is. Okay, so colder air exerts more pressure on a column of air, and warmer air expands it upwards. But the altimeter is just reading an air density amount of pressure against the bellows, right? And it's always reading 15,000 feet. And as the column of air rises, it rises and goes down. So true altitude is pressure altitude converted for temperature. So the way you do that with your whiz wheel is you figure out what the pressure altitude is. You can do that with there are two methods that I told you. You can quickly change your altimeter to 2992 and read it at your pressure altitude, or you can take whatever altimeter setting you have and subtract it from 2992 and then correct it from the indicated altitude. You may find that you're not going to clear that mountain, or you may find that you've got lots of room. Okay, so that's true altitude. Absolute altitude, I've used that word a few times, is basically AGL. All right, how high you really are above um, above ground elevation. So that's above ground elevation. So that's your absolute altitude, because anything lower than that, you smack into the ground. Indicated altitude, basically it's pressure altitude corrected for corrected by being able to turn the knob, which means that if there's a lower pressure system in, then your altimeter is going to read differently than on a standard pressure day or the day before or the next day. So in other words, it's always correcting down to mean sea level by whatever field elevation it is, based on the pressure of the system that's around the airport on that day. Okay. So the indicated altitude is basically a pressure altitude measuring device with the ability to adjust, all right, the inches mercury display, and that of course affects the altitude setting higher or lower. All right, so that's indicated altitude. It's a pressure altimeter. When you set it to 2992, it gives you accurate pressure altitude for the location you're in, regardless of what air system you're in. And then number 7 is density altitude. And density altitude has nothing to do with height, but it has everything to do with aircraft performance, right? It's the thickness of the air, right? The temperature of the air, and the moisture content in your air. Now, if you go into your pilot operating handbook, you'll see these takeoff and landing performance charts. You'll notice that they have different pressure, altitude, field elevations, which you can figure out using that method I just told you about. And then they have columns with different day temperatures. Okay, so standard temperature, below standard temperature, above standard temperature. Okay, so the 3 worst things for aircraft performance is high, hot, and wet. Okay, because those are all things that decrease the density of air, which is what the wings push against to fly. And so obviously it's going to take a lot more runway to take off on a high density altitude day. All right, so like imagine you're taking off from an airport in Halifax, 15 degrees Celsius, no humidity. The airplane's going to get pretty good performance. All right, it's going to be pretty close to the pilot operating handbook. And then you all of a sudden you're in Calgary and you're at 4,500 feet and it's 30 degrees Celsius and there's a lot of moisture in the air, which is not common in Calgary to have the moisture. But at any rate, imagine, okay, so the air is way less dense. So the wings just don't have as many molecules to beat against, to push up against, and have downwash from to create lift. So it's going to take a lot more runway and a lot more speed on the ground to get that airspeed that you need to take off, right? So high density altitude days are poor for performance, takeoff and landing. Takes more runway to land, more runway to take off. And low density altitude days are nice, wintertime, where you get great aircraft performance. The engine's got lots of air to gobble up to mix with the fuel. The wings have got nice thick air to push up against. The soup is thicker. All right. The soup is thinner at 4,500 feet, especially on a hot day when there's moisture. You'll notice that you don't see any moisture corrections in your pilot operating handbook. They sort of factor that in. Um, they take the worst case scenario. Yeah. So, anyways, I hope that was helpful to you. I may post a picture here as a reference to go against. Just going back, so we talked about sea level pressure, altimeter setting. What is an altimeter setting? It's basically depending on the conditions of the day, corrected to mean sea level, which would give you a reading of your field elevation. If you put that setting, inches mercury, directly in the window of the altimeter, it'll actually, the indicated altitude will show your field height. All right. Um, Pressure altitude, which is basically when you set your altimeter to 2992, it's the pressure altitude. Okay, it's the actual kind of imagining the thickness of the air and what that altitude would be in a perfect scenario. Number 4, true altitude, which is pressure altitude corrected for temperature and then applied to your indicated altitude. And number 5, absolute altitude, which is just your height above the ground. And number 6, indicated altitude, which is what your altimeter will give you, reasonably accurate as long as you have the altimeter setting set right, as far as the fine folks at Nav Canada Meteorology give you. And density altitude, which has nothing to do with the height of an airplane, but everything to do with the performance, takeoff and landing performance of the aircraft. Yeah, so there you are. Another video. Have a great day. And maybe the next time I talk to you, I'll be in Canada. Who knows? We'll see.